Okay, welcome. This is 14.2, quadratic formula. So we're talking about the quadratic formula and how to use it to solve quadratic equations. Okay, so we have a standard form here that we talked about before. Right, standard form is given by this, right? And we remember these, we can identify what the A is, what the B is, what the C is, right? Remember when we're factoring, use the X factor or X box, we're able to identify what the A, B, and C are. And then all we're doing with the next step is using it in our quadratic formula. And the quadratic formula traditionally looks like this, right here. Right, and then there's a song to remember it. Let's do it. Okay, so we get X. Okay, it's like a nursery rhyme. Like the Itsy Bitsy Spider, like, or X equals opposite B plus or minus square root B squared minus 4AC all over 2A. Right there, or the jack in the box. Right, so X equals opposite B plus or minus square root B squared minus 4AC all over 2A. Alright, that's going to help you to remember it and never forget the quadratic formula if you use that song. Okay, remember right here, this is important, that in order to use the quadratic formula, has to be equal to 0. Right, one side must only contain 0 in order for the quadratic formula to work. That's very important. Okay, and we're going to break this down and separate our quadratic formula so it looks like this right here. So we still get X equals opposite B plus or minus square root B squared minus 4AC all over 2A. So this over 2A and this over 2A. Same thing, means exactly the same thing, all over 2A. Right, and the plus or minus symbol, it just means that we have one is positive, like plus, and one is minus. Okay. And then this part right here, this specific part here, right, this part is the axis of symmetry, gives us the axis of symmetry, and which is the x coordinate of the vertex, and we talked about before too. The axis of symmetry is the x coordinate of the vertex. Okay, so this part is the axis of symmetry. Right there. Right, and the remaining part, this part, where we have plus or minus, that is going to be like the distance. Right, so distance right or left to the x-intercepts. Right, distance right or left to x-intercepts. Right, so it gives axis symmetry right through the middle. We go right so far to x-axis to the x-intercept, go left to x-intercept. So that's how the quadratic formula is broken down. And that's why we separate it for this part. Okay, so let's use this right here. So example we have our A, right? So A is 1. We have -8 is our B, 12 is C. And we're just going to put that in the quadratic formula, right? So opposite B, right? So that's -8, which will give us +8, 2 times 1 over 2, and then -8 squared, right? 64, minus 4 times 1 times 12, which is 48. And we get 16. Square root of 16 is 2, or 4, and then 4 divided by 2 is 2. Okay, this first part is our axis of symmetry right there. All right, so that's the axis of symmetry, 4. That's our axis of symmetry, and our solutions are going to be these two values. So since it's plus or minus, right? plus or minus. Right, so we adding and then we subtracting. So 4 plus 2 and 4 minus 2, so 4 plus or minus. So we get 6 and 2 as our two solutions. So you can see in our graph, 6 and 2 are right here, right? 6 and 2, because this is 2, this is 6. Those are two solutions. So it gives us the two x-intercepts, and in the middle, right here, is our axis of symmetry, and it goes through 4, right? And that's our axis of symmetry, which is 4, which is right there. X equals 4. Okay, so that's basically how it works. And I'm going to show a few examples here too. So again, we did our problem, we did A, B, C, substituting our quadratic formula. For our axis symmetry here, we got -3, right? So our axis symmetry here is at -3. And we notice our solutions. So -3 plus or minus 1. So our x-intercept, -2 and -4, right? Those 2 points. Okay, so that's what the quadratic formula tells us. Where the axis symmetry is, and also where the x-intercepts are. Okay. Okay, so examples. Okay, first one. Then we do 3 examples. First one, identify what the A, B, and C are. Right, so A is 1, B 4, C is 3. Right, we know how to do that. Then we're going to put that into our quadratic formula. So x equals negative or opposite, and our B is 4. So we put 4 over 4 over 2a, so 2 times our a, which is 1, plus or minus square root, then b squared minus 4ac. So we'll make the parentheses there. Right, all over 2a. So it's going to enter our values, right? So our b is 4, so we put 4. Our a is 1, and then c is 3, right? 4ac, all over 2a, right? So a is 1 again. All right, so we substitute our values a, b, and c into the quadratic formula, and then we're just going to break this down. We're going to simplify it. So we get -4 over 2 times 1 is 2. So that first part, so -4 over 2, 4 divided by 2 is 2, right? So this is -2 for the front, right? The first part. And remember, that part tells us the axis of symmetry. Right, so this is axis of symmetry. So x equals -2 is our axis of symmetry. Okay, and then we gotta do the other part to find our solutions, right? Our x-intercepts. So square root, or just go step by step. 4 squared is 4 times 4. We're multiplying 4 twice, right? 16 minus 4 times 1 times 3 is 12. All over 2 times 1, which is 2. And then we keep going. 16 minus 12 is 4. All over 2. And we still have -2 plus or minus square root of 4. Right? Remember, square root of 4, if you broke down 4, will be 2 times 2. Alright, so that'll be square root of 2 times 2. Take out your pair, it comes in the front, right? So this is just 2. Alright, so we get 2, the numerator, right? put that right there, 2. The square root of 4 is 2, 2 on the bottom. And then we can divide that, right? So -2 plus or minus, and then 2 divided by 2, 1. And always remember, separate, and we do plus or minus, right? So plus or minus these two parts, right? So we got -2 plus 1, or -2 minus 1, right? Plus or minus. We got the two different ones. So -2 plus 1 is -1. So that's one solution. -2 minus 1 is -3. All right, so our two solutions when x is -3, comma, and -1. So two different answers. Okay, so all we did was identify what the A, B, and C are, put it in our quadratic formula. The first part in the front gives us our axis of symmetry, this number. And then when we do the right side, that's what we plus or minus to our axis of symmetry to find our solutions, our x-intercepts, right there. Let's do one more, right? Identify what the A, B, and C are. So 1 again. So 1, -7, and 10. Right, so we got equals negative, and then your B is -7, right? So B is -7, so you're just gonna put that right there. So -7 over 2 times A plus or minus square root. And we're just gonna put all this in there. B squared minus 4AC all over 2A. Right, so 2 times A, so A is 1. Our B is -7 minus 4AC, so A is 1, C is 10, all over 2A, right? So 2 times 1. Right, so that's our steps, right? Identify. A, B, C, and then substitute it. Yeah, the first part. So we got -7. So negative is a positive, so it's positive 7 over 2. So 7 over 2 is a fraction. We divide it, it's a decimal. So we can just leave it as 7 over 2. It's like 3.5. I can't. The axis of symmetry equals 7 over 2, which is 3.5. And we can write that too, 3.5. Usually leave it as a fraction, but that's okay. Plus or minus. And then we do the other part. So -7 squared, -7 times -7, positive 49. Minus 4 times 1 times 10, 40. Over 2 times 1, 2. 49 minus 40 is 9. Inside the square root, still over 2. So 3.5 plus or minus square root of 9. Again, right? So 9 is 3 times 3. So that's your pair. Right, so that's going to come out right there. So we have 3. All right, so we put that in a fraction. So we have 3 over 2. And you can kind of think of it, 3 over 2 is 1.5, right? So it's different ways to look at it. You also can do fractions. Let's make it a fraction. See what it is. No, let's leave it. Okay, we get 3.5 plus or minus 3 over 2 is 1.5. All right, then we're gonna add or subtract, right? We're gonna separate this thing. So we get 3.5 plus 1.5 and 3.5 minus 1.5. Right, so 3.5 minus 1.5 is 2. 3.5 or 3.5 plus 1.5 is 5. 3.5 minus 1.5 is 2. So our solutions in order be 2, 5. Usually least to greatest. 2, 5. So the next one. You identify our A, B, C. So 1, negative 5, positive 2. Then we're going to substitute our values. Negative, and then B is negative 5. Negative 5 there. 2A plus or minus square root. I'm going to put all my parentheses here. So all I have to do is write our numbers in there. So A is 1 again. Your B is negative 5. For AC, A is 1, C is 2. And then A on the bottom is 1. Then we're going to calculate it, right? So negative, negative 5. So negative, negative 5 will be positive 5. So positive 5 over 2 times 1, which is 2. Right, and that's our axis of symmetry. 5 over 2. Let's see if there's a fraction this time. So 5 over 2. Axis of symmetry. Then let's break this down. All right, so negative 5 squared is 25 minus 4 times 1 times 2, which is 8, all over 2. We get 5 over 2 plus or minus 25 minus 8. What's that? Square root of 17, all over 2. And you look, can you break down square root of 17? Is that possible? Right, because 17, can you factor 17? Right, so it's just 1 times 17. That's it. All right, so 1 times, so it's already factored. You cannot take out any pairs because there is no pairs. So if that's the case, you leave it like this. So this is your answer right here. Right there. That's your solution. Right, so if cannot simplify, leave as is. Leave it that is. The way it is. Alright, so your solution, that will be just the whole thing to put in there. 5 over 2 plus or minus square root of 17 over 2. And that's your solutions. And you still have the 2 solutions, right? Because you can separate them. Like 5 plus square root of 17 over 2. Or 5 over 2 plus subtract square root of 17 over 2. So we still have our 2 solutions. We just writing it as one solution together. But it's, just remember we have 2 solutions because one is addition, one is subtraction. Okay, so that's a square using the quadratic formula to help us find what the axis of symmetry is. Right, the axis of symmetry right down the middle, and then we add or subtract to that to find the x-intercept, your solutions.